Hello there, and then welcome to a brand new video on our limit series. Now in this video, I do hope that you have watched the two previous ones that explains all we need to know before solving any question on limit. In this particular video, we are just looking at how to look for the limit of polynomial functions. That is the basic questions you can even get or you can ever get on what limit. So how do we solve limits of polynomial functions? When we say polynomials, what are polynomials? Polynomials are simply functions of this form over here. I wouldn't go into it because this is limits video. I wouldn't be treating polynomials, but then just to take a quick review, any function that is being written in the form x to the power, let me start from 5. So 5 plus x to the power 4 plus x to the power 3, and then going on and on and on. All we want to say is the value you have over here should be decreasing as you move along, and then at least there should be let's say coefficients over here as well, right? So this is just an overview of polynomial. You can just pause and then read through all this if you really want to know what polynomials are. But then to get the limits of polynomials, all we do is we substitute the values of x into our functions. Just substitute the value of where you want your limits into the function. The reason being that polynomials are continuous functions. They are defined on every point. So since they are defined on every point, the limit at that particular point exists. So let's quickly look at some examples and then how we are going to solve these limits of the polynomials. Our first example here, our polynomial p of x is given by x squared plus 3x plus 2. Now, after solving, I'll do my best to illustrate it on a diagram for us to have a feel of it graphically. So what do we want to do? We want the limit of this polynomial as x is approaching 1. So what you do is, our solution, we know p of x. We know p of x is given by x squared plus 3x plus 2. We want the limit as x is approaching 1. So the limit of this function x squared plus 3x plus 2 as x approaches 1 is simply given by, since it is a polynomial, we are going to look at the value of the polynomial at x equals 1, and that will be our limit. So how do we solve that? The value of our polynomial as x equals 1 is simply substituting the value of x. So wherever we see x, we put 1 there. That is, we have 1 squared, that is x squared, then plus 3x. So plus 3 into bracket 1, and then plus 2. Then we do our evaluation. 1 squared gives us 1, plus 3 squared gives us 3 times 1 gives us 3, then plus 2. And evaluating this further, we have 1 plus 3 giving us 4, 4 plus 2 giving us 6. So this implies that the limit of the function, what we wanted, x squared plus 3x plus 1, as x approaches 1 is equal to 6. As simple as that. Do you see? So when it comes to evaluating limits, especially when they are polynomials, you just substitute your values. So let's look at how this looks graphically. So graphically, this is what you have over here. The blue line here is the plot of what? X. It's the plot of p of x. That is our polynomial function. Now, as x equals 1, this is the line that we have used to intersect. And if you would just look at it this way, that is, if you would just use your ruler to trace out the point we have where these two lines intersect, you see this over here, you would see that you are going to have your 6, just as we solved. So let me plot that. You see, so just as we solve, we are getting our 6. So solving for limits, it doesn't only restrict to the algebraic method. You can always do it graphically. But the problem is most times we are not able to plot the graph and then there is less time. Let's quickly look at our next example. So let's quickly solve this second one, and at the end I'll show the graphical view. Our solution, we know our p of x is given by 2x cubed minus 5x squared plus x minus 7. Do you see? Now we want the limit. We want the limit of this same. So let me just write p of x. So we want the limit of p of x as x approaches negative 2. And we have said that since this is a polynomial, it is simply equal to the value of p at negative 2. The value of our polynomial is negative 2. Hence, let's just solve for the value of the polynomial at negative 2. That means that we are going to get 2 into bracket our x, which is negative 2. So we have negative 2 to the power 3, then minus 5 into bracket our x, whose value is what? Negative 2 to the power 2, then plus another x, whose value is negative 2. Do you see? They will now have our minus 7. So simplifying further, we have 2 times negative 2 to the power 3 gives us negative 8. Note that if you have a negative value raised to the power a positive integer, raised to the power an odd integer, you are still going to get a negative answer. So you have 2 times negative 8, then minus 5 times negative 2 squared gives us 4. That is negative 2 times negative 2. Then we have negative 2 minus 7, which is 9. Simplifying further, we have 2 times negative 8, which gives us a negative 19. Negative 5 times 4 gives us negative 20. Then we have negative 9. So we add all of this. That is negative 19 to negative 20 to negative 9, which gives us negative 48. So this here is the limit of our function. So it implies that the limit of our function p of x as x approaches negative 2 is what? Negative 48. So let's go to the graphics and then see if what we did was really true. Now, this blue line here is what our function we want. And then we want the limit at x equals negative 2 as x equals negative 2. So let me take my ruler and then we measure that and see if it's going to give us negative. We had 48. So I'm bringing it here. Now, mind you, look at the function you have over here. So it is rather doing what? This, because negative 10 here is far less than negative 20, so it is increasing. So let me bring that here. And as you can see, I have put my ruler exactly at the point of intersection. So let me draw a line to show where we have our point. I hope you can see that. So look at it over here. And you had negative 60 here. Negative 50 will certainly be around this point here. You see, and it is going, it is increasing. So our negative 48 would be there. So at this point, I do hope you understand how to look for what we call limits of polynomial functions. I do hope you understand how to look for limits of polynomial functions. Let's look at our very last example, then we can end this video. Okay, so this here says p of x is equal to what? X to the power 4 minus 6x squared plus 9. and we want the limit as x approaches 0. The limit as our x approaches 0. So how do we go about it? Now that you understand, you can even pause at this point and then try your hands so that you now play and then see if what you did was in order. Okay, so if you paused, well done, and then if you're able to solve it, that's an applause. Let's do it together. We have our function p of x being equal to x to the power 4 minus 6x squared plus 9. Let me call this p of x. So the limits of p of x as x approaches 0 is simply the value of p of x at what? 0. So we now solve for p at 0. That is our polynomial when the value x is equal to 0. As we did in the previous one, you are just substituting 0 for all the x you see. So you have 0 to the power 4 from this here. Then minus 6 into bracket 0 squared. And then plus 9. Let's do our evaluation. 0 to the power 4 gives us 0. Minus 6 into bracket 0 to the power 2 still gives us 0. Then plus 9. So we have 0 minus 0 plus 9, which gives us what? A positive 9. So this simply implies that the limit of x to the power 4 minus 6x squared plus 9 as x approaches 0 is 9. As simple as that. This one was very simple because we were working with 0. So I just believe, or I do believe you are able to solve it. So looking at the graphics of it all, this blue line here is the function, the polynomial function. It wanted the limit at x equals 0. Now the red line here is where we have our x equals 0. So I'll just move my ruler to x equals 0. And as you can see, it is exactly on the point what? 9. Or I can choose to draw a line to illustrate that. So this is my line here. Easy. And you can see the point it touches exactly on our 9. Alright. So I do hope after this video and then at this point you can fully and then confidently solve limits of functions of polynomial functions. Alright. So simply put, if you want to find the limit of a polynomial, you just identify the polynomial and then directly substitute the value of x into the polynomial. You simplify your expression, and that is all. Thank you very much for staying to the end of this video. If this is your first time watching this series, this is the Hub Beyond Numbers. Hub Beyond Numbers, where we do our best to learn maths the easy way. I try to include visuals in our solution so that at least we have a feel of it. Kindly subscribe if you found this video helpful, and from time to time you can let me know any question at all you'd want me to solve for you for your personal needs. That is if it is maths related. My contact is just the one on the scroll there on Telegram, OJOBODI. You can let me know and then I'll be glad to help you. Stay tuned for our next video, still on limits. Stay safe.